Okay, here's homework number 2. So, oops, I need a pencil. What is today? 3-11. So, yesterday we talked about what acceleration is. If there's some object that has a steady force on it, then the velocity will change steadily. These style of problems, where you know the acceleration, because that's the change in velocity over change in time, are called constant acceleration kinematics. We created a formula yesterday that looked like this, velocity versus time. If the velocity changes steadily because there's steady acceleration, then the slope was the acceleration, this would be v initial, and this is v final. And we said yesterday, or in class, that this area actually stands for something. It stands for the displacement of the car, how far the car's gone. So in a situation where there's steady velocity, if this was 2 meters per second and this was 3 seconds, then this displacement would be 6 meters. That's still true if the slope is changing. So we created some sort of formulas that are really just only true for constant acceleration. The one we did yesterday is just y equals mx plus b, where v final, some future velocity, is the slope times the x-axis. Okay, so if this looked like this, you'd write y equals the slope times the x-axis plus the y-intercept. Well, that's what this formula is. Then we had another formula we created where the displacement is the area of this trapezoid. This part, though, is just a box. So this part, so the displacement would be the area of the box, which is v initial times t, plus the area of the triangle above it, which, doing some magic, comes out 1/2 at squared. So this is kinematics equation 1. This is kinematic equation 2. If I solve equation 1 for time and then plug it into number 2, we get the third equation, where there's no time involved. So choosing the correct equation for the situation means you need to understand which variables there are. There's v initial, there's v final, there's acceleration, there's time, and there's displacement. If you know 3 of these, one of these formulas will give you the fourth. So anytime you know 3 of these kinematic variables, you can find a fourth. So let's look at an example. Okay. An example. Let's see if I can do this. A file. Oops. A file. Files. Let's look at this. So here's a teacher who, go to the first slide, has a sort of a format for this. So here it says there's a Boeing jumbo jet, okay, with 400 passengers. None of that matters. Its takeoff speed is 350 kilometers per hour, and there's the length of the runway. And they want to know if the plane accelerates with constant acceleration from rest, what is the acceleration needed? So this teacher says, okay, first I'm going to draw a picture of the airplane. There, I'll make it that. And the beginning velocity is 0. It's got some length of runway. What did it say it was? 3.32 kilometers. So we learned earlier in this class how to convert things so that we can all have just meters, kilograms, and seconds. So it even has a little space down here for that conversion. So 3.32 kilometers each kilometer is 1,000 meters. So the length of the runway is 3,320 meters. All the units have to be meters, kilograms, or seconds so that all the units work out. Okay. He also says that the velocity was 350 kilometers per hour. That's the speed it needs in order to take off. Okay, well, that's not the right units. So I'll do that up here where there's room. 350 kilometers per hour. Let's see, 1 hour is 60 minutes. And 1 kilometer, kilometer is 1,000 meters. And so that's how you convert, because we did that in class, kilometers per hour to meters per second, because all the units have to be MKS or SI or whatever your teacher calls them. So let me do that conversion really quick. Hang on a second. I just realized I have meters per minute. I need meters per second. Oops. I screwed up my own problem. So let me do one more step here and say, let's see, there's minutes in the denominator, so I'll go 1 minute is 60 seconds, then get the answer. Sorry about that. Okay, I got 97.2 meters per second. That's the velocity the airplane apparently needs, okay? Now, I don't know how I'm supposed to fit that conversion down here, but let's pretend I did. So this teacher says, okay, let's look at a velocity time graph for this airplane. Velocity time. It's going to start from rest. It has to reach a velocity, a final velocity of 97.2. And it has to do that in 3,320 meters. So let's see, I know V initial is 0. V final is 97.2 meters per second. I know that the displacement is, where did I write that? 3,320 meters. And I'm trying to find the acceleration. So I need to find the equation that has the correct variables. The equation that has all these variables, look, there's no time, is this one. Okay? So there's the equation I need. I'm going to plug in my knowns, V initial 0. So I'm going to say V final, 97.2 meters per second squared equals 2 times A times delta x, which was 3,320 meters. So I can solve this for acceleration. So I'll divide both sides by 2, divide both sides by 3,320. That comes out squared over 2 over 3,320 meters. And that gives me, unless I messed up my calculator, 1.42 meters per second squared. That's the acceleration I need for this plane to be able to accelerate to a final velocity in the distance that's provided. Okay? So the units check. Let's look at just the units of this part. I have meters over seconds with a squared on top, and on the bottom I have meters. That's going to turn into meters squared over seconds squared over that meters. If I pretend that's meters over 1 and invert and multiply, that puts the 1 over meter up here, and I get, that cancels one of those, meters per second squared. So the units do come out acceleration like I expect. Now, for now, let's just skip this, what is the force part? Okay, I'm going to give you 2 of these to do. So there'll be a link for the video, followed by a link for 2 more of these. Okay? And that'll be your homework for tonight. Just fill in the boxes like I just did. I hope that makes sense. Okay.